Hello. Okay, so I think I have to talk into this for, it's a record. Yeah, but I don't think you need it for, okay. Yes, talk loudly. I might have to get an hour done this way. Hello everyone, how are you feeling? 9 a.m. on a Sunday. I'm very happy to see each one of you because I was like, there's going to be 3 people in this talk. So I'm extremely excited, so thank you. Yeah, I got super sick last year. I was sick for 5 days and I was quarantined in London. And they would not let me fly back home. I had to stay in a hotel. So yeah, I'm glad to be here this time without getting as sick. So this talk has been kind of inspired like over probably the last year and a half. Just a bunch of different, so I guess I'll back up and say, okay, so I've been doing container stuff since like the sub 1.0 release of Docker. And now at Red Hat, I am the product manager. I'm like the primary product manager that drives our container images. So like I build the Red Hat Enterprise Linux base images, which are now UBI, Red Hat Universal Base Image, which I'll talk about a little bit in place. But so I think about this stuff all the time, and I get a ton of questions around this. And I'm also the product manager for Cryo. And how many of you know what Cryo is? All right, I won't bore you with it, but it's still cool that some of you know. And then how many of you know what Podman is? More. Okay, that's good, because I'm also the product manager for that. And then Builda and Scopio. And it used to be Docker when we, well, still technically, I guess, because we do support it in RHEL 7, so I'm still the product manager for Docker as well. But yeah, so I basically eat, sleep, and breathe this stuff for like the last 5 years. And so this started culminating in my mind. All right, like, I'll get into it, but there's like this, I don't know, every time something new comes out, everybody says, oh, the old thing's dead, and now there's this new thing, and everything, nobody cares about the old thing, and this is just like how people, I don't know, this is like maybe politics, this is technology, this is everything, I don't know. But yeah, so I published a blog entry on opensource.com, and it was fairly popular, it was decent, it did pretty well, and so like, I was like, yeah, maybe I should do this as a talk. I think I was talking with you, and you actually told me I should do a talk, and I was like, oh, I guess I should do that. And then it was a culmination of that and the fact that I came upon this. So it's an interesting comment, or it's an interesting concept where people undervalue, like in economics, there's the concept of discounting, right? Like you'll subconsciously discount certain things, and then you will overvalue other things. So like, you know, like if you see a lion, you're gonna run away from the lion, but then you could starve to death because you discounted the fact that you actually also had to go get food. People discount maintenance. So like, I used to say, until somebody corrected me, that like, you know, when a bridge is built, people have a tuxedo dinner. And then when the road crew comes in to resurface it 20 years later, nobody cares, right? Like they get Taco Bell or kebab, you know, at the end of the day. But I was corrected by a civil engineer that said they definitely do not get tuxedo dinners because apparently they can barely pay for bridges. So now I use like the skyscraper example, right? Like when a bank builds a skyscraper because they have a lot of money, I'm guessing there's a tuxedo dinner. But we value innovation, and we even do this everywhere that I've seen. Even in our planning meeting last week, I noticed like everyone claps when we're doing this new thing, and everyone claps. But then when like we fix the old thing, everyone's like, oh, that's cool. But like we don't care. Like, and so like I started going through my mind. I'm like, ooh, I mean, we basically undervalue what's in the container image because it's essentially a Linux distribution. And so I've seen this multiple times from people. Twitter drives me crazy, but this is probably a quote I've seen on Twitter more than once. Like, how many of you care about the operating system? All right, I can leave. I'm done. All right, I've already cut to the chase. You'll see this comment, like, especially people with containers. And I guess, how many of you were in Daniel Reek's talk yesterday? Any of you? One, okay, a couple. So he talked about how there's 2 ways to look at an operating system. I almost stole a slide, but I decided I'd talk about this anyway. You can look at it from the bottom up, and you can look at the operating system as enabling the hardware. And like, you know, the Linux kernel can enable certain pieces of hardware, blah, blah, blah. But then when you run your app, it looks the same no matter what kind of hardware, as long as it's like x86 hardware or ARM or Power or whatever. But, you know, given different architectures, it looks the same. And then you can look at it from the top down, which is something that I'm a systems person, so it's not something that I had historically done early in my career. I looked at it always from the bottom up. But top down, you look at it as an application platform where if I write my app once, it should work in other places, right? Mostly for this talk, I am going to tackle it from the top down because I think we all know that like you still need a Linux kernel to boot up hardware. But we're moving to cloud, and everybody's talking about how you're running like containers on, a cloud platform. That is a VM that's a fairly generic VM, and it is fairly easy to light up because they're pretty standard. So I think the more interesting problem for at least developers and people that are thinking about this is in the container. And I think this is where people are really blind to the fact that it still matters. So let's start with something not technical, and then I'm going to hurt your brains in the middle, and then I'll calm down again and stop hurting your brains. But let's use tires as an example. I joke, like, how many of you have kids? So how many of you care about your tires? How many of you would have said that before I asked you if you had kids? Like, we don't think about it, right? Like, okay, so minivan is one thing. This is a very common vehicle in the U.S. I know you guys don't have as many here, but the idea that when I hear people say, well, I don't care about the operating system, or they're like, I don't care about my tires, I'm like, I think you do. Like, if you have a family in your car, I think you care about the tires. I think it gets, especially in the winter, rain, I think you start to go, oh, there are certain variables I do care about with the tires, right? Like, I don't just want them to, like, blow out when we're on the expressway and, like, crash the car off the road, right? So I care somewhat, like, at least care a little bit. And then I go, well, here's a higher end car. Do you care about your tires with this? Like, how many of you own, like, sports sedans? None of you. So he might care a little bit. I know, right? Yeah, these just came over to the U.S., I think. And they're stupid expensive there, too. But then you start getting into this territory. It's not quite professional, but I think I don't own one of these. I don't think any of us do. Does anyone own a Ferrari? All right, good. I'm talking to my people. But I think they care about their tires. I would think that once you have that much money, you don't care. Like, you're like, just give me the best tires, put new ones on, I'm done. And then when you're in this scenario, you definitely care about the tires, right? And I would argue this is where we should be thinking if we're professionals. So, like, how many of you do any kind of, like, computer stuff for a living? Like, work? Okay, exactly. So, like, we should all be thinking in this category, right? Like, you would never go to an F1 mechanic who's like, yeah, I don't care about the tires. I care about the new carbon fiber wings we're putting on this. Nobody says that. Like, if you're a professional, you worry about all the components that go into that, thing that you're doing, right? So, like, if I'm a sysadmin by trade, mostly, I guess most of my career, software engineer and sysadmin, I care about the operating system because it's part of the things I got to care about. I still care about Kubernetes. Actually with Kubernetes and containers, there's a lot more to care about too, but I don't think anything went away, right? Like, I think there's just more stuff to worry about. So, all right, so yeah, I basically said, safety I care about here, probably road performance, at least this is a common thing in the U.S. People will go out and drive through the mountains, like on the weekends. They care about their tires. If you blow out your tires driving through the mountains, you will die. Like, you'll slide off the road and die. Here, these people definitely care. And then here's where we should be, right? Like I said, this is really us, I think, the professionals. All right, so maybe I've convinced you care a little bit. Like, most of you already cared, but how many of you care now about the operating system? I think it was all the same people. I don't think I've convinced anyone. Politics. All right, so what context, though, right? I love showing this picture because I think this is actually a genius picture in that, like, people think that, this is still more efficient than not doing that, right? Like, if there's a bunch of crap piled up on that boat, it would be less efficient. But some crane probably put it in there, right? Like, so that still went, on a big ship and then into a smaller, who knows what, onto a crane and then onto a truck, and now it's on this boat for the last mile and maybe go to some island. Like, there's still something interesting about containers. I won't go on too much of a tangent about that, but I've always said it's a packaging format. I think that proves it. All right, so there's a lot of different options. I work for Red Hat, but I still value all of these Linux distributions, I'll say, and even Windows. At this point, you kind of have to say, well, if I'm running Windows, I need Windows containers. You have to kind of care about, you especially in Windows world have to care about what's in the container because they have to match. You can't even have different versions. Like, there's no ability to, like, leak. But in the container world, how many of you have been using, actually, let me ask this. How many of you have used Docker? Vast majority. Some of you have used Podman, I saw. How many of you have been using containers for more than 3 years? Decent amount. How many more than 5? So a few. Yeah, it was us that were, like, talking about all this early on. And how many of you more than a year? So actually, it looks like the last year shot up a decent amount. It looks like it almost doubled if I were to take a quick estimate. So, like, we're still in that phase where people are figuring this out. So these are two of the common patterns that I've seen. And admittedly, as an old, like, curmudgeonly old person now that I might not show off, but I've been doing this way too long. I see people trying to reinvent the wheel. They look at these minimal options. This has become very popular in containers. And they'll say, well, we use distroless. We don't want to use a Linux distro. Or they'll say, we start from scratch. And I'm like, eh. But then on the other hand, some people have common sense and they go, I'm just going to use a Linux distro. I'm going to use what is already there. I'm a Debian user. I want to put Debian in the container because now I can, apt-get all the dependencies, blah, blah, blah. But there's two schools of thought happening. And I would say this is the hipster cool, and these are like the old curmudgeons, in general, or people that just don't think about it. But I would argue that it's still pretty valuable to think about this. All right. So I was joking. I had the sticker. I didn't put it on there. But there is no cloud, right? There's just someone else's computer. Have you all heard that? But there's also no distro list. There's only dependencies that you manage. So you have to think about this. Actually, here's the funnier part. How many of you know about what distro list is? Have you heard about this? All right. Do you know what they actually use?
Probably something big, and then they hammer it down.
It's a Debian dependency tree. They rely on the Debian Linux distro to do the work for them. And so it's funny because I think it's almost it almost reminds me of politics in 2020. We say things like distroless. And I'm like, there's a whole team of people working on that behind the scenes, and you're basically minimizing everything they do of value, but yet you're using it. It's a complete insanity. So hopefully I've caught you ahead of time before you see distroless, and now I've put you back on the right path. There's no such thing. There is no such thing as distroless. All right, so why would we use a Linux distro? You would think through the standard reasons that you would use a Linux distro at all. Why would you use it in a container image? It's basically the same reasons. I try to boil these down. Obviously, some of these get into things Red Hat would think about more, but I think these are pretty common among all the Linux distros, right? Size, what core utils does it use, what C library, what lifecycle, how long will they patch it, how long will they patch what's in that container. People don't realize when you go from, I ranted about this because on Docker Hub, the CentOS 7 and CentOS 8 container images are actually in the same repository. So if you're using the latest tag and you're building, when CentOS 8 came out, all of your stuff probably just stopped working. And so you just did a Linux migration in 10 minutes, or 5 minutes, however long it took to rebuild your containers. This is something that's it's hard for them to get their brain around. They don't realize, every time I rebuild that container image, I'm essentially reinstalling the operating system. And then when I go from major version to major version, that's an actual upgrade. I have to invest engineering time in going from a major version of Linux to another major version of a Linux. And that could require reading tons of docs, figuring out they went from SendMail to Postgres. I remember when that happened. These kinds of things matter, right? You have to think through this. So the life cycle in a container matters probably even more, because I think VMs would probably get even lazier and we don't pay attention for a long time. And then eventually we're like, oh crap, the latest tag just pulled the latest version. Now I've got to figure out what's broken and why, what programs changed. So I think these are pretty important things to think about in containers. I mentioned security. I go a step further and think about a security response team and looking at it. I don't want to say anything bad, but different Linux distributions have different qualities there. Some are more reputed in their ability to, think about patching and actually patching things. Other ones are less. So I think that's pretty important. Being able to quickly track down, when the security team comes to you and they scan your entire container environment, they're like, you have all these CVEs, you have to patch these things, and that typical feedback thing that happens in any professional environment, that's going to happen with containers, and it already is. And then automate. I talk about automated, automation and performance engineering, basically proactively going out and making sure. I show a bunch of them here instead of just one because I think it's pretty funny. But as you scale up and you have more containers, here's one of the weirdest problems that can happen in containers. And this is, I always find these edge cases and then they happen and then I laugh because I try to tell the world, but they don't listen to me. This is a problem. I haven't seen a BZ for it yet, although I've seen the BZs for all the other ones I've predicted so far. This one is going to happen soon, where you're building a web app and you're building it and you're running it on Kubernetes, and you're putting your performance at say 200 milliseconds. I need the web server to respond in 200 milliseconds, and I fire up 10 containers, and I have a certain level of traffic load that's coming out and trying to connect to it. What happens when 3 years from now, Kubernetes just kept firing up more containers? You're still getting a 200 millisecond response time, but now there's 72 containers. and you're like, wait, what happened to, like, Kubernetes will just fire up more containers, even if like some performance went completely sideways inside of your container. You wouldn't even notice because it's just load balancing traffic. So like, this is something that people are not thinking through, like the glibc, the way the web server's compiled, all the standard stuff that we care about in Linux distros still matters in a container. In fact, it might even matter more because the platform will go fire up more of them and make things work. And next thing you'll know, you'll be spending way more money on Amazon because you have like 22 more virtual machines because you needed that much capacity because you had a performance hit, and Kubernetes just fixed it for you by adding more containers. So let's go into like how all this works, so to remind you and go a step deeper. So this is where I'm going to hurt your brain a little bit. We invented all of this a long, long time ago. Since only 2 of you were in Daniel's talk, he went through the entire history of like Unix to now, and we were messing with him afterwards. But I have a couple of blogs where I do go through this entire history. I will skip most of the history and come up to like 25-ish years ago. The idea that we could So I show here, this is actually becoming a trendy thing to do in containers again, where people do scratch builds, what they'll call scratch builds. But nobody really knows what that means. Sometimes it means pulling binaries from a Linux distribution and running them, basically stuffing them or putting them in the container. But then other times it means compiling like a C app or like a Golang app, which we have a lot of in our container team because there's a lot of tools in the container world that are written in Golang, and Golang is compiled. This is seems like a really good idea at first. You're like, oh, this gets the smallest container image possible, right? Because I get a very small binary if I compile everything statically, and I don't have any dynamic linking. And all I need is glibc or Golang or something like that, and I can compile it in, and I come out with a real small binary, and then I stuff that binary in a container. But this has some really strange caveats in that, one, if I have 5,000 containers in my environment, I now have 5,000 glibcs embedded everywhere, and I have 5,000 different SSLs, libSSLs embedded everywhere. And now we get into the nuanced problem of attack surface. People think it's the container image. They'll do this very not smart thing where they'll look at the container image. They're like, this container image is bigger than this container image, so this one has less attack surface. And that's actually not the way you should look at it. You should think about all of the containers in your environment and think about the attack surface of all of that. And if you have 200 different teams using 200 different versions of libSSL and 200 versions of glibc, now you have a much larger attack surface because the hacker does not care about that one container. They're trying to get into your entire environment. Their target is the environment. So the more different containers with different versions of glibc and libSSL in them, the worse this is going to be, right? So many years ago, we solved this problem by doing dynamic linking. And what we do here, I show in this example, is I'm compiling Apache, and for those of you that don't remember this, what happens when you dynamically compile a binary is you add ld.so. Basically, you statically compile in ld.so, and then when you run the binary, the Linux operating system is smart enough to analyze the ELF binary and go, oh, this has a dynamic linker, and then the linker at runtime will go out and find the dependencies on the disk. I don't know how many of you remember this, but this goes back to computer science, like back 20 years for me. Now, the beauty of this is we've turned on more technologies, and I'm showing you kind of like how we get to a container and then like which technologies get turned on as we get into this. And this is all about, I should have explained this at the beginning, but this is, I'm going to build up a container image and kind of go further and further and further until we truly have a container. But now we're using ELF binaries, we're using glibc, GCC, and glibc inside, and then we're using LD. And now we start to go, okay, now this is cool because if libSSL or glibc need patch because there's some security problem or some performance problem, I can patch it. I can patch it without basically recompiling the app every time. But I still have to rebuild the container every time. So there's still a problem there. And then we've also introduced a new problem of now we have dependencies. We have to figure out how to get these dependencies on disk inside the container image. So now basically we've said, oh, well, now we need to build something called a depth solver, right? Oh, well, in this case, Red Hat World, it's Yum and RPM. And then I turn on this technology that I call Linux distro. Linux distro is a bunch of human beings that have subject matter expertise in a bunch of different pieces of software. They compile all of this software into one giant repository, and then they build out all the dependencies for that. And it's a nightmare. And honestly, except for operating system people and Linux distro people, nobody wants to do that work, right? Like as a developer, I'm trying to build a PHP app. I don't want to do that. I don't want to have to go to hunt down all the like glibc dependencies or the libSSL dependencies, things like that. It's a nightmare. So we've now solved that problem, but now we have a Linux distro. We're back to having a Linux distro inside of the container image because I want to have that dependency tree basically. But that only solves the bottom-up part of the problem inside the container image. We still have to worry about like PHP, or Python or NPM for Node. We still typically end up layering on some kind of application on top, like Perl, Python, Ruby, PHP, blah, blah, blah. And almost all of these languages have their own dependency, their own depth solver, and their own supply chain of dependencies. And there's teams that go and analyze and basically manage all that, and that's a ton of work. So now you're getting into, I got 2 different dependency trees. I have Linux distro, and then I have some language, maybe multiple. And now I have depth solvers for both. And I have to have access to all of this tooling at the time that I'm building the container image, basically. It's almost like, again, you're kind of back to an operating system install. But we go one more layer. So this is really where we get into like the technologies that truly make a container, right? Because if you think about what a container is, it's not much. It's a tar file, and it's got a config file, and that's about it. And you could have multiple tar files depending on how many layers you have. And then I joke here, we have the Open Containers Initiative governs the specification. It's an open. I don't know how many of you do you know what OCI is? Not many? Okay. So Open Containers Initiative is managed by the Linux Foundation. It is an open governing board that basically but governs the format of container images and actually runtimes, and they actually have sort of a reference implementation of the runtime standard, which is runC, which I don't go deep in this talk, but this organization is really cool, and that Docker gave this to this organization. There was some politics at the beginning to get this to happen, but luckily it did happen. And so now, at least in the container format world, we're never going to end up with RPM and deb. We won't have a split thing. At least everybody's going to use the same OCI spec. And there have actually been a few others, like how many of you have heard of Singularity? Singularity is another different format. LXC has its own stuff, or LXD has their own thing. Oh, I didn't know that. Yeah, so there's still people nibbling at doing other things, but I can tell you right now, at Red Hat, we are doing this. Like, this is the one that everything else. There are downsides to the specification. Alex Sarai from SUSE has a great talk where he talks about all the downsides of the current technology that we selected for basically container images, and he has all of these solutions. But it's going to be like the next 20 years to get any of them done because we have a working standard. I'm even seeing in my world where people are less interested in Singularity and more interested in OCI containers, especially in the last year. Like, it started to change. Whereas before, I think people didn't realize the beauty of having one container spec is that I can have one piece of infrastructure. I can have one registry server that has everything in it. In fact, I think CNV or KubeVirt can even pull virtual machine images from within an OCI basically image file. And I know for a fact CoreOS in OpenShift 4. I don't know how many of you have heard of CoreOS, but it's the basic distribution of RHEL that we snapshot for OpenShift, and it's a read-only operating system. It actually pulls down its updates as container images, lays them out on disk, and then updates the OS. So like we're moving to this for basically, if you look at OpenShift 4, it needs one thing. It needs a container registry. That's all it needs to manage OpenShift. It even manages the operating system updates as container images. So, but these container images are basically a bunch of metadata and some architecture-specific stuff, all stuffed in a config file, and then basically we basically just put that in with the image layer side by side, and then the container engine, which I won't go deep into it, but when it pulls down the container image and runs it, it knows how to digest these variables that the image builder has put inside of the container image. But now this is kind of all the technologies working together to make something, basically a manageable container image that will work, that will be constructive, and we can use over an operational life cycle, like 3 years or 2 years or 5 years or longer sometimes. I still hold to the fact that people will use technology for a longer period than they want to. Like, the container world is under this impression that we move fast, so we will only have things for like a year or 6 months. But in reality, I guarantee there will be container images that are like 10 years old, and they'll keep rebuilding them until whatever bits you have in there are not updatable anymore. All right, so then this opens us up. The fact that containers are also layerable. So the way container images work is that config file points to like what layers make up that container image. And then when the container engine goes and pulls down that config file, and it looks and it says, oh, I need this layer, this layer, this layer, it pulls those layers down, and then it lays them over each other. So like if you want to delete a file, you actually have to, this is another one that Alexis Rye does, he rants about it. He's like, when you want to delete a file, the container image doesn't get smaller, it gets bigger, because you have to write metadata saying you deleted the file in the layer below. So like say you have a 5 gig, ISO image in the base image, and then you delete it in another container, layer on top. You will now have 5 gigs still there, plus like the metadata pointing back that says, hey, I deleted the 5 gig file. It doesn't go away. So there's some good and bad things to this. You can do things, and I'll show you at the end, where you can delegate to different specialists. Like say, historically, you've always had sort of sysadmins, DBAs, Java specialists. You can start to delegate some of the work in different layers to different teams and let them add things. But it also has some downsides if you don't do it right. So in this one, I point out, I don't have names for all these problems, but this is like the I've overwritten something without realizing it, and I've actually increased my attack surface. So in this one, what I'm showing is this person built a container image on top of this person's. Like this might be like the operating system team built some base image. Then this team came in and built another one where they wrote Apache or Nginx, and then but they didn't overwrite glibc. So at least if this team goes and patches glibc, this team will inherit it. But then this team said they needed some other libSSL that was newer, that had some, or compiled in a different way, that had some other encryption options or who knows what. And then this team needed a different glibc for who knows why. And the problem here now is that like when this person rebuilds libSSL, this person doesn't get that update. And when this person rebuilds glibc, this person doesn't. And so this image might have CVEs that show up that aren't in this one and aren't in this one and aren't in this one. And so you end up with this layering problem where you have this like cascading effect. And you have to really think through this. And I've seen some organizations have very, very complex supply chains where it might be 35 different branches to the tree, and they're very complex. And then they have to figure out what in computer security we would call non-repudiation, where this team says we didn't add it. It must have been the team ahead of us, and it has some Trojan in the image, right? And then you're like, who added it? You can only point to the next person in the chain and say it was somebody above me. It wasn't me. And there's plausible deniability if you don't have basically non-repudiation. So sometimes people will do things like put a signed file in that container image layer to verify that team actually put that together. It's not super perfect, but it's better than having no idea who did what. So this is kind of what the container images in their full glory look like. So also, I already talked through layers. But with image layers, you basically get to communicate to the end user, like what these different layers mean. And you can think about these as basically human constructs, right? Like these are arbitrary. The OCI doesn't govern what you put in these images. So I've seen people do nasty stuff where they have like Apache configured one way and Apache configured another way, and they branch, and it'll be like Apache 1, Apache 2, and they'll have like different configs embedded in this. You can do that. I would not recommend it, but you can do that. This latest tag is the only one that's governed. But these don't have to be numbers. In this case, I show that, and I try to explain this as this is a way for the container image builder to communicate to the container image consumer how they should consume the image. And really what this is about simplifying the API surface of the thing that you're getting, right? You're like, hey, here's a container image. I don't know which layers are usable, but there could be 25 layers, but I'm going to label a few of them so that the end user knows how to, what they should be consuming and why. It makes it more intuitive. And I already talked about, like these layers kind of come together, and then I give a quick overview here of like how this gets at runtime, what happens. So this is the container engine. This is Docker or Podman or Cryo. Cryo, any container engine has 3 jobs basically. It's basically to build this config file is one of the main jobs, and what it does to build this config file that then gets handed off to run C to then basically talk to the kernel and run a container is it actually uses the default variables that were embedded inside the container image, and then it will add user options. So like say you say podman run -p 8080:80, and you like map port 8080 to 80 when you're running the container image. That's basically these user options that would override any port settings that maybe you had embedded in the container image. And then the engine itself will add all kinds of other things like SE Linux rules or setcomp rules, or there's all, if you look at a config file, which I don't do a demo in this one, but if you look at a config file, it's 400 lines long, and it has all these setcomp rules and all these things that the container engine itself adds in. And then finally, it passes this config file off to run C, which I mentioned is the OCI reference implementation for a container runtime. And both Podman and Docker and CRI, all three of them use, and Containerd. Basically, everybody in the world uses run C. And so you hand this config file off to run C, and then run C talks to the kernel to fire up a container. I kind of mentioned that already, but I also show here how it can get, in this one, I showed basically a smaller tree, but this is getting now what it really starts to look like in a real environment, right? Like we may have like a operating systems team that kind of builds a base image, basically pulls down, say, a Debian image or a Fedora image or CentOS or whatever, RHEL, and then adds some things that they think they want that are kind of standard things that they'd like to have. And then, you start to specialize. Like this might be an Apache team, this might be an Nginx team, this might be a MySQL team. And this is where we start to like break things out, by SMEs, right? But as you start, the reason why I'm boring you with all of these details is you start to realize there's a lot of other problems I should be working and thinking about than just like I shouldn't be like questioning whether I'm going to use Yum and Ruby gems and NPN, right? I should be thinking, I have to think through all these layers of things. And to be very honest, I'd rather spend more of my time here. I'd rather spend more of my time like setting up a CI/CD system and figuring out how I can make this like CentOS container image build over and over for 5 years without having to think about it. And so like that's where I got to the life cycle matters, because the life cycle of the Linux distro in the container image essentially governs how long I can let this thing run in a CI/CD system, constantly rebuilding and always like actually having the updates it needs to have security, performance, etc. But in a nutshell, I want to focus most of my time and attention up here, not down here. So obviously, like an operating system still matters even in a container image. All right, so I mentioned like some of the problems that like these things solve, right? Just having a container image starts to help the works on my laptop problem, because I did bundle all those things together, right? Like I bundled the PHP and everything together. And if I test that construct, that I call it like a jiggly stack of software, right? Like all the different versions of these things can change, but once I've cement them in a container image, at least I know I snapshot it. It's almost like a core build, like we used to do back in the day, or we still do. But I have it saved forever, and then I can run on my laptop, move it into production. I pretty much know it's going to work. Like I pretty much know it's going to work. There's some caveats depending on, people will mix and match. I'm not a big fan of that. They'll be running like Ubuntu here and they'll run RHEL here. I'm not a big fan of that, because if you're running binaries from one Linux distro and another, I do prefer, let's say in this scenario you're using a Red Hat Universal Base Image on an Ubuntu laptop and then you move it over to RHEL. I like that better than going the other way, because like if it ran on Ubuntu in development, it will only run as good or better on the operating system that it was basically compiled on. And so I think there's less danger going from like something that wasn't compatible to something that we know is for sure compatible. But going the other way, I think, is a very dangerous way. Like I typically suggest to people to, if you're going to have an Ubuntu server, run an Ubuntu server image, because those binaries were compiled with that kernel, and all the, like for example, with RHEL, SE Linux, everything is dialed in, everything is like the way it should be in those binaries, and so things won't break, which we've seen that happen. That's probably been the biggest. One of the problems I saw was like an Ubuntu image was ran on Ubuntu, and then they moved it over to CentOS in production, and the CentOS had SE Linux turned on, and then basically the binaries that were compiled in Ubuntu actually had SE Linux options on, which nobody knew, and then they like came on and broke the binaries, but there was no way to like change it around in the container image because the tools were not there. Does that make sense to everyone? So another problem I mentioned was, my containers, like I'm in a big Kubernetes environment and they just keep scaling out, right? Like, and I could still get, like, say when I first put the application into production, I need 1 million transactions per second. I might be able to achieve that on day one, but how do I maintain like 1 million transactions per second? And like I mentioned, on day one, I might deploy 1,000 containers to achieve 1 million transactions per second. That's the way you start to think in a Kubernetes environment. But then, like 3 years from then, I might have like 1,500 containers running to get the same 1 million transactions per second. And nobody will ever notice. No, there's no like monitoring or fault management that we use that would ever catch that. That would just be like decay in whatever you had in that container image. You might have made a config file change at some point that then made it need 33% more resources, or you might have made some SSL change that was like, caused it to use a different algorithm that was less efficient, or the operating system could have updated a binary in there and then things broke down the road and caused it to use more, resources. So these problems get very tricky when you start to move them into essentially a distributed systems environment like Kubernetes. And so again, I suggest offloading that problem to an operating system or to like a Linux distro, because the Linux distro is good at doing this already. Another one is I have the million transactions per second, then I have the hacker. Works on my laptop doesn't help you with performance or security. Like, just because it works on your laptop does not mean it doesn't get hacked 2 seconds after you put it into production, right? So how do you even have any kind of warm and fuzzy feeling that it's not going to get hacked? You can like compile it yourself and be like, well, I think I know this stuff pretty well. Or you can use something that like a Linux distro is already building, and you're like, well, there's a whole bunch of other people using it and they're not getting hacked. So now I have precedent that I probably won't get hacked also. So it's another nuanced reason to think about using a Linux distro in the container image. And then here I just break out, there's a whole bunch of other user space things you need to think about with performance, especially like compute. There's a ton of work that goes into Linux distros to make sure that basically all of these capabilities remain the same. So like in any Linux distro, when they bring it together for the next version, they basically compile things with glibc or whatever compiler they use, and then you like start to like make little tweaks and kind of set a baseline of performance for all these things. If you are again doing all this from scratch, every time you basically make a little tweak to it, it's almost like you just create a new operating system. So if you're back at that model where you're like, we're going to compile everything ourselves, do all this ourselves, manage all these things, and you give that all to the app team, every different container image in your environment is going to have essentially different performance characteristics with all of these things. And that can become that can be a pretty heavy cognitive load, and it can just be inefficiency. Again, it's not attack surface, it's like work surface or maintenance surface. You're creating a huge maintenance surface because all these different container images may have different performance characteristics, which will inevitably bite you, down the road when it's in production. 3 years from now, when that team's gone and they don't even know how it works anymore. And it's just sitting there in a CI/CD system being rebuilt, and you're like, it works kind of, but I don't know what it is. It's a bad place. I already predict this is happening to people that have done this. I talk a little bit about Red Hat Universal Base Image. I won't go deep, but Red Hat saw this problem. So RHEL, historically, we had always charged a subscription for, right? And so this container world turned my world upside down, and this has been my life for the last year and a half, or about a year. In that we had to figure out how to basically put some RHEL bits out there so that people could use them to basically do all the things I just said, rely on a Linux distro inside of the container image, while still being able to redistribute the Linux image. Whereas historically Red Hat had not let people redistribute RHEL. We basically used the trademarks. It was kind of the only way that we could enforce our business model that basically allowed a contractual agreement. Because the way Red Hat's business works is there's no legality. Like the customer could totally share their stuff wherever they want, but they sign a contract that says they won't, and we sign a contract that says we'll give you support as long as we both agree to this contract. That's basically the only enforcement we have. So we basically created this thing called Red Hat Universal Base Image that changes that end user license agreement to allow people to redistribute them. And we did introduce Node.js and Java and PHP. Actually, we're introducing Java soon. PHP, a whole bunch of different language runtimes, and then we have sort of 3 standard base images, a minimal one that you can run systemd inside the container image. How many of you would think about running systemd in a container image? All right, so some people are pretty pragmatic. Personally, I actually defend this, even though, again, I'm kind of a curmudgeon, but there's a lot of subject matter expertise built into that. And if you've ever been tasked with building a container image for some piece of software that you don't know, and then you have to figure out how to get it to start up with a single line, it's really annoying. So Apache, you can run httpd-d background, and there's a few command line options you can pass that daemon to run, but it's annoying because I don't want to go into the systemd file and find out how you start all these different pieces of software that I'm running in container. It's much easier in a container image build to do yum install Apache systemctl enable httpd. And to be honest with you, I even run mine. I run even my blog and all my stuff as essentially systemd ran Apache that just starts with 2 commands, and then I actually run them read only. So I actually get systemd and Apache running in a container read-only, and so like it's pretty secure. Like it's definitely more secure than running on a regular web server. So this does not preclude doing really serious security things, even if you're running like systemd. And anybody that says systemd eats up a bunch of resources is probably crazy. Like it's not like running Apache and then systemd side by side for the small scale I'm doing is not a big deal. Anyway, so let's get to we're getting down to the end here, but let's go with some actually, before I even give any recommendations, because this is my world now we're getting into where I'm constantly thinking about this stuff, but how many of you are actually involved in a Linux distro, like contribute to one? Okay, so a decent amount. So I'm curious, like those of you that do, how many of you have seen similar problems like from your users asking about things in the container image? Has anyone asked anything? A little bit? All right, a little bit. But you're kind of looking, not that much. Are those of you that are working on this thinking about specific features or changes that you can make to your Linux distro to make it run better in a Linux in a container image? Raise your hand if you're doing that. So some, okay. Yeah, and I would say I'm in that boat. I'm thinking about things, and we do certain things, but it's still pretty much a regular Linux, like rootfs basically for this at this point for the most part, even for us. So I joke again. I decided to put up something funny to show like how containers happen, basically. I'll let you read it for a second. This is basically what we did with containers, right? Like we just glued two phones together to make a tablet because we wanted to split screen, right? Like it's still basically a regular operating system inside the container image. And we're not doing that much. We're just gluing new stuff together in a slightly different way. Some tar files and some config files. That's basically what we added to this whole magic. So I guess, especially the other people that work on distros, like the call to action, I think, is first off, all of us telling the world the same thing. Like telling people that this still does matter and having confidence that matters. I noticed early on at Red Hat, because I've been doing this like 6 years-ish, I would say early on, some of our packagers and stuff didn't fully feel confident that this mattered. Like I would say we kind of slapped some things together in containers early on, and then we eventually built out an entire huge team to like handle all this. But I was like the Cassandra whining early on that this is going to go sideways if we don't think about it, especially container image rebuilds, because it takes a lot of image rebuilds when you get into these layers like this. I mean, Red Hat has several million container image builds per month, probably. We're in that scale. I mean, it's a huge environment. We don't actually talk about it publicly a lot, but we could easily do like one of those high scalability blog entries on how we do all of our container image builds. It gets huge. But I think all of us should be telling the world that this still matters. Like the dependency tree that we build matters, and like the value, the quality of that dependency tree, and all the subject matter expertise for all of those packagers matters. You know, like our packager on our subsystem team, I work on the container subsystem in RHEL, but like our packagers know how to build Podman better than other people know how to build Podman because they build it all the time, and they know like all the little secrets to make Podman run better in the way that we want to run. And that's true for like Bind and Apache and like every other like, you know, type of software that you put in there. And then you scale that out across an entire Linux distro, and now you're talking thousands of pieces of software. So I would say my call to action for, or ask for everyone, you know, is like, think through that and like tell the world that your stuff still matters. Like don't let people say that, you know, it doesn't matter. Then the second thing I would say is let's think about like features that we can add to our Linux distros basically that will start to make it more optimized for container images. There's all kinds of things that we're thinking through right now. Like, for example, like I would say MySQL is a perfect example. There's a bunch of environment variables that like the official MySQL image or the official MariaDB image will accept. Like you could pass the database user the database password. There's like probably, I don't know, 10-ish different environment variables. We should all start to think about how the Linux distro can do that out of the box. Like for Apache, like imagine if you could set like the encryption algorithms that you want to use or the security level of the container image. Those are like really nice to have things that I think probably the Linux distro should start to think about doing. You know, again, optimizing tool, you know, for example, we have FIPS compliance is a perfect example for us, for Red Hat. We have to be able to turn on like the FIPS algorithms inside the container image. And we do it actually by setting some variables in the host, and then the container engine is smart enough to basically know that and then run the container image in a certain way. But this requires a lot of moving parts. It's the way the container basically the way the container engine is built and compiled and configured, and it's also the way the container images are built and compiled and configured. And so you end up with this dependency tree where you can make things kind of magically happen and make them a lot easier. You know, I would say same defaults are another thing, like making sure that these things come up in the right way and start in the right way. That would be good for a container image. Think about another one is minimization. I think a lot of us, anybody that's probably doing this, the ones that raise your hand, like minimization is probably the biggest one that I hear among the dependency tree. And we're working on that. I don't know how many of you are from Fedora, but we're working on that upstream. Adam Samalik is working on a minimization effort upstream because the way Red Hat does everything, we just do it upstream. So probably around the RHEL 9 timeframe, you'll see this work end up arriving in RHEL. But I would say that's a huge one where we really want to optimize the dependency graph basically so that we can have loose or weak dependencies and then make things smaller and maybe even break up some of the packages in new ways. So like maybe you know, libSSL, we could break it out, or especially glibc is one that we can break out into different things. We did it a little bit with like languages, so the lang packs, we have like a default minimal language pack that we can pull in with glibc to make it smaller, but we want to do more and more stuff like that. But I guess my call to action to everyone, especially the ones that work on distros, is let's all start thinking about this stuff and like make our stuff relevant in this future world, because it annoys me when people say that operating systems don't matter. I think there's a ton of work to do here. And so with that, I will leave you with my Twitter and some other stuff I wrote. I publish a lot. So like if you Google me, I write like all kinds of crazy stuff about this. I probably publish, I don't know, 20 blog entries a year, 30 blog entries a year or something. But I would love to continue the conversation if you want to chat about it. And I will leave it to questions if anyone wants to do any questions or even thoughts. Especially the other distro maintainers, I'm curious.
Thank you for the talk. You've mentioned breakage with the latest tag on Docker, but in Open Linux we're having quite a problem with users not using the latest tag and then complaining that the Docker images have some CVEs open because they don't update their stuff. So how should this just handle that?
That is hard. Yeah, I'll repeat. Sorry. So he said they're having actually a problem. So there's a problem to use the latest tag or not to use the latest tag. If the end user that pulls down the container image specifies essentially a tag, on whether it's the latest or not latest, you get burned one way or the other. What happens is if they pull the latest, it will constantly break them, possibly. But if they pull down a static, like version 1.2, you know, like if they pull down a static version, that image, I say container images age like cheese, not like wine. And so they will end up picking up CVEs over time. And then they complain no matter what you do. Like they want, so the short answer there is it's a hard problem to solve. Red Hat solves it because we do API compatibility over a life cycle. So we guarantee, so like if you pull down a RHEL 7 image, or it will stay RHEL 7 forever, it keeps getting CVEs, but it doesn't break anything. But it's a hard problem to solve. That's a lot of investment, and that's kind of why we do it. But that's the only way I know to solve that problem.
Or you can use stable time.
I'm sorry, say that one more.
Use stable time. So you stay update on stable time.
Yeah, well, that's essentially what I'm doing. Yeah. Oh, sorry. So it wasn't a question, but I'll repeat. He said you can stay on the stable branch. So, for example, with Podman upstream, we have stable branches that we actually rebase down into RHEL. We basically just follow those stable branches, and if there's a CVE, we'll patch the CVE there, and then anybody can pull it. So, like even SUSE contributes a lot to Podman, but they can just pull down the stable version. That is one way to solve it. That hopefully the upstream will maintain those CVEs. For some things you can probably do that, like MySQL and other things. Any other questions?
This is from University. Do you have anyone thinking about how to understand the relationship between the container and OptOS? I'm in HPC, and we often want to do things like
Crazy stuff?
the system API into the container so that we can use the network, or expose the GPU to the container
Yep.
from the host. And so there's a real conflict between making portable images and, and having them perform well. So, like, we recently ran into a glibc forward compatibility problem, which I did not think could happen.
Yep.
But you take a container built for an old OS, you find out the new API link to a newer glibc into it, and you resolve the old glibc with the new glibc call. So, yeah, what are you guys doing to enable that?
So this question is around host and container image compatibility, which I love ranting about, and HPC proves it. And what they do, what he said, is they basically will bind mount in things like the MPI library or glibc from the host. They may like have a directory that has like a specific version of glibc or the MPI libraries built, or like Cray has their own MPI library, and then you have to like use that one.
Yeah, and they don't know what they're doing.
Yeah. So the question is, what are we doing? And I may know you by your question. Like, I think I might know who you are. Have you ever been on a call for the like Sandia Labs and all those HPC things? Okay. So I may have talked to you before. This sounds like such a familiar problem. But the question is, what is Red Hat doing to try to make them better? Well, it's kind of the same answer as the last question. Like, what we do is try to maintain that API compatibility. So at least if it's a RHEL 8 or UBI 8 image on RHEL 8, that should work, right? Like even if you're using the underlying host glibcs, everything should work. And then hopefully the ecosystem of RHEL is big enough to attract like the hardware and all that stuff so it'll enable it, right? And we are doing a lot of that in OpenShift and in RHEL.
Do you have a tool to expose the ABI, like as a spec, like not just check the compatibility, right? Or not just, I use RHEL in my container.
No, there's an ABI like there's.
Here's a spec. You can check it against the host OS. I know this will work. Instead of the current policy, which is like this container works until it explodes and then you rebuild it.
Yeah. So his question is there a way to like basically compare two ABIs and kind of diff them?
Yeah, you guys have Abigail and stuff.
We do have some kind of tooling to do that. I think we mostly do it to check old versions against newer versions to make sure we didn't break compatibility, but I don't see why you couldn't use it to compare two different container images. I know Carlos O'Donnell is a really good guy to talk to about that. He's a Red Hat guy that's a glibc maintainer. And I know he talks about this all the time. This is like deep in his area. I don't know that we've built anything that we expose to end users to do that, but we definitely do it internally. We definitely do it in between like RHEL versions and things like that. So you could probably use that. Actually, I'm sure if you Google, we talk about it publicly, but admittedly I haven't gotten deep in that. But that's an interesting one. We should chat more about that one. I think we should probably wrap it up. So thank you, everyone.